Hi, in section 7.1 we'll be looking at angles. So drawing angles in standard position. A ray is a directed line segment consisting of one point on a line and all points extending in one direction. So here's a picture of what a ray would look like. You have an endpoint and then you have a line going in one direction only. An angle is the union of two rays having a common endpoint. So if I draw another ray with the same endpoint, that is going to create an angle. The common endpoint is called the vertex. So this point here is called the vertex. All right, let's see what else we can learn about this. Down below, there's a picture of an angle. As you can see, this is called the initial side, and this is called the terminal side. And the direction at which the angle goes is counterclockwise, which is positive, the positive direction. And if you go clockwise, that would be going in the negative direction. Okay, let's look at the next page. So an angle is in standard position if the vertex is located at the origin and its initial side extends along the positive x-axis. So if you have an axis, x-axis, y-axis, and your angle starts here, that's your initial side, then your angle can go in the direction, the counterclockwise direction, and that would give you a positive angle. So the direction of rotation, positive angle measured in a counterclockwise direction, counterclockwise from from the initial side. That would be a positive angle. If you want a negative angle, that's going to be measured in a clockwise direction. That would give you a negative angle. So this would be a positive. Let's say maybe it looks like it could be possibly 135 maybe. All right. And if you had another angle that went in this direction, let's say the initial side is here, and then you go this way instead, then that would be possibly negative 45 degrees maybe. All right, so it's negative because it's going in the clockwise direction, whereas this one up here is a positive angle because it's going counterclockwise. All right, quadrantal angles. Quadrantal angles are angles, let's see how they define it. If its terminal side lies on an axis. So if the terminal side lies on the x or the y axis, then it's considered a quadrantal angle. And those would include the following angles: 0 degrees, 90, 180, 270, or 360. All right, let's look at this following exercise. It wants us to sketch the following angle in standard position. So standard position means we need to have the initial side along the positive x-axis. The vertex needs to be at the origin, and 30 degrees is approximately about right here. So we got to indicate the direction of rotation, and there it is, 30 degrees in the positive direction. Okay, for the second example, part B, they want us to draw another angle. This one, notice, is negative, so we have to start with our initial side on the positive x-axis, and this time we're going to go clockwise, 135 degrees, which would be approximately here. If you went this way, clockwise, in that direction, that would be negative 135 degrees. Perfect. Okay, let's move on to the next page. So now they're going to talk about radians. So 1 radian is the measure of a central angle of a circle that intercepts an arc length in length to the radius of that circle. All right, so let me draw a quick picture for you. If you have a circle, and let's just say this is the radius here, R, and this is the arc. And if the arc is the same length as the radius, so this is R, then this angle is 1 radian. 1 radian. That's how it's defined. All right, what you really want to know is that pi radians is equal to 180 degrees. That's the really important fact that you want to, or identity that you want to memorize. Pi radians equals 180 degrees because you're going to use that to convert from degrees to radians. So to go from degrees to radians, you want to multiply by pi over 180 degrees. All right, so you're going to multiply by that ratio to go from degrees to radians. To go from radians to degrees, you're going to multiply by the same ratio. However, you're going to multiply by the reciprocal of that. So it would be 180 degrees over pi. So let's do an example down below. So for the first example, we're going from pi over 6 radians to degrees. So since we're going from radians to degrees, we want to multiply pi over 6 radians times the ratio 180 degrees over pi. And that's going to allow us to cancel out the radians, the pi radians, and that'll give us 180 degrees divided by 6. 180 degrees divided by 6, which is 30 degrees. So that's how you convert from pi over 6 to degrees. All right, so pi over 6 is equivalent to 30 degrees. Now let's go in the other direction. Let's say we are given 15 degrees and we want to convert that to radians. So now we're going to multiply by pi over 180 degrees. That's going to allow us to cancel out the degrees. All right, and so now we're going to have 15 pi over 180, which can be simplified. If you simplify this fraction, you will get 15 goes into 15 once, and 15 goes into 180 12 times. So we end up with pi over 12 radians. All right, so 15 degrees is equivalent to pi over 12 radians. All right, now we're going to talk about coterminal angles. So coterminal angles are two angles in standard position that have the same terminal side. Same terminal side. So let me draw a picture for you. So let's say you had, let's go with 30 degrees. So let's say you had 30 degrees. And then you went around 360 degrees. Then you're going to get a new angle with the same terminal side. So if you add 360 to 30, 360 plus 30 is 390. So those two angles are considered coterminal because the terminal side lies on exactly the same place. You can also add another 360, or you can subtract 360. If you go clockwise, you would be subtracting 360. So let's this time subtract by going counterclockwise. So if you go in this direction, counterclockwise, you're gonna do 30 minus 360, which would be negative 330 degrees. So those two angles, or those three angles, are all coterminal angles. So in degrees, you can add or subtract 360 degrees to any angle to find a coterminal angle. In radians, the equivalent to 360 is 2 pi. So you can add or subtract 2 pi to any angle in radians in order to get a coterminal angle. All right, let's do some examples down below. So let's find the least positive angle, theta, that is coterminal to 800. So you start with 800, and you can subtract because they want the least positive angle, 360. If you do that, you should get 440. All right, notice that you can still subtract 360 again because they want the least positive angle. So let's subtract 360 one more time. And if you do that, you'll end up with 80 degrees. So that's going to be the least positive angle that is coterminal, because if you subtract 360 one more time, you'll end up with a negative angle, which they don't want. They want the least positive angle. So 80 degrees would be the least positive coterminal angle to 800. All right, they also, for the next exercise, they want us to find an angle, beta, such that is coterminal to 19 pi over 4. So they want our beta to be between 0 and 2 pi. All right, currently 19/4 is bigger than 2. So let's subtract 2 pi, because that's what you're supposed to do. You're supposed to subtract 2 pi or add 2 pi, but in this case, we want our beta to be smaller than 2 pi, so we got to subtract. So we got 19 pi over 4 minus 2 pi. Let's put the 2 pi over 1, and our common denominator will be 4, so times 4 times 4, that's going to give us 19 pi minus 8 pi, which is 11 pi over 4. And notice that that is still bigger than 2 pi. 11/4 is bigger than 2 pi. So we can subtract 2 pi yet again. All right, once again, common denominator is 4, so multiply top and bottom of this fraction by 4. And that's going to give us 11 pi minus 8 pi, which is 3/4 pi. 3/4 pi is less than 2 pi, so that is going to do it. That angle is coterminal to 19/4 pi. Okay, let's move on to the next page. All right, in this, now they're going to talk about arc length. So in a circle of radius r, the length of an arc s subtended by an angle with measured theta is in radians is given by the formula s equals r times theta. So notice that the angle must be in radians, so that's very important. The angle must be in radians. If you're given an angle in degrees, you must convert it to radians before you use this formula. So this formula only works when the theta, when the angle theta is given in radians. Okay, this is the arc length. They use S as a notation for arc length. R is the radius, and theta is the central angle. All right, so if you're trying to find this length, S, you're going to use this formula, R times theta. Okay, let's do an example. So here we go. Find the arc length along a circle of radius 10 units subtended by an angle of 215. So they give you the reminder to convert to radians first. That's our first step. So we know how to do that. So we have to multiply the angle 215 by pi over 180 degrees. We can cancel out the degrees, which will leave us with radians. So now we're going to end up with 215 pi over 180. Okay, and you can simplify that. If you simplify that fraction, you will get 43 over 36 pi. Okay, once you have that, now you have the angle theta in radians, so that's our theta. Now we can use our formula for arc length, S equals R times theta, which would be the radius is 10, and the angle is 43 pi over 36. Okay, and if you use your calculator for these type of problems, they're going to want a decimal, so you can use a decimal. Let's round to 1 decimal place. If you do that, you should get 37.5 would be the length of the arc length. Okay, let's look at the next topic, which is the area of a sector. So here's a sector of a circle. It's shaded in blue. To find the area of that, the formula is given by A equals 1/2 theta r squared. Okay, you can see the formula here. It's a little small, but there it is. So that's how you would find the area of a sector. And once again, don't forget that theta must be in radians again for this as well. If it's in degrees, then you must convert it, just like we did up in the previous example. Okay, let's move on to the next page to try an example that involves area of a sector. All right, an automatic lawn sprinkler sprays a distance of 20 feet while rotating 30 degrees. What is the area of the sector of grass the sprinkler waters? So they're giving us a sector of a circle. The radius is 20, and the central angle is 30 degrees, which we need to convert to radians. So let's do that first. So 30 degrees, so we're going to multiply that by the ratio of pi over 180 degrees. Cancel out the degrees, and now we should get 30 pi over 180, which is going to simplify to pi over 6. Okay, now that we have theta, now we can apply the formula. So the formula, if you recall from the previous page, is 1/2 theta r squared. Okay, so that's going to be 1/2 times pi over 6 times 20 squared, which if you do this on the calculator, once again, we want a decimal for this. If you round to one decimal place, you should get 104.7, and the units are in feet, so area would be units squared, so feet squared. Okay, the last thing they talk about in this section is about linear and angular speed. So angular speed is given by the notation omega. It's a Greek letter, and they give us a formula. Omega is equal to theta over time. Sometimes it's useful to know to solve for theta. So let's solve for theta. To solve for theta, you would multiply both sides of the equation by t. So times t times t. You can cross out the t's over here. And so you end up with the formula theta is equal to omega times time. Sometimes it's useful to have that formula, as you will see down below. So that's angular speed. For linear speed is uses the notation v for velocity, the distance traveled, the arc length per unit time. Okay, so we're going to use these two formulas to come up with the relationship between linear and angular speed. Okay, omega is the angular speed, and v is the linear speed. So we already know that s is equal to r times theta, so we can make that substitution. So we have v equals s over t. That's the formula that you see up over here to the right. If we replace or substitute r theta for s, you're going to have r times theta over t. And now we're going to replace theta with omega t, because theta is equal to omega t. So we're going to do the substitution here now. Instead of theta, we're going to call that omega times time. Over time, as you can see, the t's cancel, and so we end up with r times omega. So that's the relationship between linear velocity and angular speed. So v is equal to r times omega. Okay, let's put this into a use in the following exercise. A bicycle has wheels 28 inches in diameter. So we need the radius. So we're going to have to divide that diameter by 2 to get the radius. Let's start with that. The radius is going to be 28 divided by 2, which is 14 inches. So now we have the radius. A tachometer determines the wheels are rotating at 180 revolutions per minute, RPMs. Find the linear speed the bicycle is traveling in inches per minute. Okay, so first thing we got to do is convert 180 RPMs into, we need to convert it into radians per minute. So to convert that, we're going to use this conversion here. Let's start with 180 revolutions per minute. That's what an RPM is. And we're going to multiply by, since we know that 1 revolution is equivalent to 2 pi, because 2 pi is 360 degrees. So 1 complete revolution is equivalent to 360 degrees, which is equivalent to 2 pi. So now we can cancel out the revolutions, and now we have radians per minute, which is exactly what we needed. So this is going to equal to 360 pi radians per minute. And that's That's how omega is defined, as radians per unit time. So here it is. Omega is in radians per unit time. In this case, it's radians per minute. Okay, now that we have omega and we have the radius, now we can find the linear speed. So now all we have to do is use our formula. Okay, so the formula is V equals R times omega. R is 14. Omega is 360 pi per minute. And so if you use your calculator, your decimal should be 15,833.6 inches, because that's what the units are for a radius, per minute. So that's the speed that the bicycle is traveling. And that completes this section.